This is the video solution for homework number 9, which applies to all sections, all lab sections. The problem that we have is a base here, and on it there is a disk. Inside the disk there is a path and a block which is sliding in that disk. The block is sliding as shown, starting at the center, sliding down, and the disk has the ability to rotate. What we like to do is write a few lines of code so that it emulates this kind of kinematic information. So it says that t equal to 0, the block is at the origin. Then between 0 and 4 seconds, the disk, the disk rotates by 30 RPM, which is 180 degrees per second, by the way. And the block travels in the direction away from the center at 2 inches per second. When time is between 4 and 9 seconds, then something else happens. And then finally, when the time is between 9 and 10 seconds, the disk returns to the original position, and the block turns in the reverse direction. Now, this can be done, as I discussed this thing in class, this can be done in two different ways. One of them is using the rules, which is available in the knowledge toolbar. And then the other one is switching to Knowledge Advisor Workbench and using laws, okay? So the first thing I'm going to do is to create this assembly. In this assembly, the only thing that I make sure is that the radius of this thing is, let's say, 9 inches long. And the reason I do this is that notice that this disc moves away 8 inches and then returns back to the original position. Okay, so there is nothing important about the 9 inches radius that I'm going to make, but that's fine. If I make it too big, then the block will, just basically space that's wasted. Okay, or if it make it too small, you're going to say, oh, why is the block leaving the rotating disc? Okay, so I'll make it 9 inches. Now, the GAs, the way they're going to mark this is after you do all your stuff and you send them the CATIA file, the product file, and all the parts file. There's 3 of them here, right? You also have to send them some graphs, and the graphs should look like this, because these graphs, the one on the left and the one on the right, actually displays the information above, and that's how the GAs are going to mark it. If what you submit is not these, then you must have done something wrong in the program. Okay. All right. So let's go ahead here and start with the product file. Okay. Right away we save it. File, save management, save as, desktop, new folder. We'll call it 1, and excuse me, I'll call it homework 9. Where is it? 1, homework 9, right there. Okay, then I'm going to make the base is just this cylinder. So insert, new part in there. Right click, properties, base, and base. And we're going to make it. So on a convenient plane, on that horizontal plane, I will draw a circle and pad. Let me make this so that it resembles the diagram that I have in my in the statement of the problem. Let me make this thing 10. This is not this is not uh, the disk of this. This is going. I said I was going to make it uh, 18. Okay, let me make this thing 20. Diameter 20. Exit. Pad it by 1. Make this thing a little bit smaller. This has no bearing on the kinematics of the problem. Okay, good. Then we're going to insert the disk. So insert new part, and we're going to call it the disk. Excuse me. Properties, disk, and disk. Double click on it. On a convenient plane, I'm going to sketch. Another circle here. This is the one that rotates. This is the part that rotates. And this gives this, I said the radius, I'm going to make it 9, so diameter 18. 18. Exit. Pad it. Okay, that's fine. All right, now I'm going to make create a path. So on that face, I will sketch here. Why don't I draw a rectangle? That's probably the easiest way of doing it. Oh, actually, yeah. Okay, good. So, yeah, I'm going to put a dimension here so that I have better control of my drawing. How about making this thing 1? Okay, exit, pocket it. How about by point maybe 2.5? See how it looks like. Okay, there we are. And then we're going to insert the block. So insert new part. Say no. Right click properties block. Block and block. Let's make it. It's just just a box spacing 1 by 1 by. Let's make it 1. So on a convenient plane, on that plane, I will, yeah, on this plane, I will sketch. Just want to walk box 1 by 1 by 1. That's all. I don't care how you do it, but I'll do it like this. Okay. And let's make it 1 by 1. This is 1 inch. And the width of it I'll also make 1 inch because I want it to fit in that track, but it doesn't have to, just doesn't mean anything. Okay, good. And pad it. Yeah, okay, that's fine. Okay, so let's go save everything. Notice it took me 5 minutes to make this piece assembly. Okay, so we're going to anchor the base. We're going to move these things away from each other so that we can easily create the constraint. Remember, there's the disk and the base has a revolute joint, and the track, the block, and the disk has a prismatic joint. So let me move these things up and up. Okay, very good. Let's start doing it. So we have a coincidence between the axis of this disk and the axis of the base, and coincidence between the top face of the base and the bottom face of the disk. Update. This is going to become a revolute joint, and a coincidence between the face. It really doesn't matter. So this side face of this and the side face of the block, and coincidence between the edge of the block and the edge of the track. Update. Now I want this thing starts all the way at the end. Is it at the end? Yep, it is at the end. Okay, very good. If not, I move it there, move it to the end by a coincidence or translation, and then create a constraint and then delete it. Remember to delete it. Okay, very good. So let's go here, save everything. All right, now we're going to go to the digital markup. Get the magic wand out. These are very simple uh, joints, so you can use the magic wand. All of them are going to get created. There's only 2 of them. One of them is prismatic, the other one is revolute. And that's why the degree of freedom is 2. Okay. Now, to create, motion, this has to be 0. So what I'm going to do is double click on the revolute, make it angle driven, 0 to 360. These, yeah, and then this one, revolute, make this thing length driven, 0 to 9, right? 0 to 9. Oh, the direction is wrong, of course. Let me flip the direction. I want it to go the other direction. Although from the kinematics point of view, it makes no difference. But for uh, test, you have to test on homework, you have to emulate the motion as it's desired, okay? On the track to the left, okay? Okay, so let's check this. There are two sliding bars here. One of them is for the disk. The other one is for the track, okay, for the block. Okay, all right. Now let's save this. Okay, what we want to do is 2 things. We want to create now. Obviously, if, for example, I knew that the speed of the disk was constant and the speed of the block was constant, then you know how to do it. Using the f of x, go and put the right formulas in there, etc., etc., etc. But okay, so what I'm going to do is the next thing is we go to create our basic the instructions of motion. We're going to go to knowledge advisor. So start knowledge where, see that knowledge where, knowledge advisor, and you see the icon up here changes, etc. And there is something there which looks like a state, looks like a, it says rules. It says if x Y, etc. You click on it, and it says there's a rule that's going to be created. Default name, you can give it a name. There's the date, and then you say OK, and this pops up. Okay, so basically you have to write your few lines of code here. Okay, so let's go ahead. Let's start with we have to follow the instructions there. So click on the mechanism. Notice that the two things associated with the mechanism are going to pop up right there, and you're going to say if time is less than 4 seconds. Don't forget to put the S here. If you put the S on purpose, I'm not going to put the S here. This is wrong, but on purpose, I'm not going to put it there because I want you to see that there's going to be a message, and you're going to have to fix it. Okay. If this, then you know that the angle comes from basically this formula, 180 degrees per second. That's the velocity. Okay. Rotational velocity is equal to 180 dEg divided by 1 second times time. Okay. Now you need braces here. You need braces. Okay. Because when you want something to be executed, once you say if dot 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 dot, obviously there's a mistake here. You need an S. But then you need the stuff to be executed going to be in the braces. Okay. And enter. And the length, I think the velocity was 2 inches per second. Velocity of the block was 2 inches per second, equal to 2 inch divided by 1s times time. So this is the first leg of the journey. Close the braces, and then you're going to say else if time less than 9. I'll put S here. This, I'm correcting it here. See, this is okay. This is wrong. Okay, we'll see that we're going to get an error message for this. Okay, and then execute the following. You need braces. Angle is equal to 720 degrees and stays there. 720 degrees DEG. And then length. Oops, on the next line. Length equal to 8 inches. 8 inches. Okay, close the braces, hit enter. All right, and finally, this is the last leg of the journey. All you have to say is else, enter, braces. Then we're going to have the angle. It goes in the reverse direction, so it's going to be from 720 degrees that it was sitting. You subtract, and the speed of that is same speed, 180 degrees divided by 1s times parentheses time minus 9 seconds, 9s, okay? And the length is equal to, remember it was at 8 inches, sitting at 8 inches, so 8 inches minus, it goes back to the origin at the speed of 8 inches per second. See that? See, here it was going 2 inches per second, but now it's returning at 8 inches per second. So that's going to be 8 inches divided by 1s times parentheses time minus 9s. Always be prepared to go back and fixing for syntax messages and things like that. The only syntax message that I can think of is that this should be s. But that's okay. Let's see that. Say okay. Right. So let's go here. This one. Okay, so double click on it. Let's check a few things here, make sure everything's okay. This, first of all, should be yes. If time is less than 4 seconds, mechanism is 180 degrees 1 second times time. Okay, very good. And length is equal to inch divided by 1 second times time. Else, if time is less than 9 seconds, they stay there. So angle is 720 degrees. Yep. And the length is 8 inches. And finally, 720 degrees minus, yep, this is the correct speed. Everything looks okay. Say okay. Yep. Now, what we're going to do is uh, double click on the commands. See, this was angle driven length. Double click on it right there. See this right there. This. You click on it. Okay, so we linked it to that. So to this rule, you can see that. Okay, and say okay, and do the same thing with the other one. Double click on the length command. That guy. Rule, puts it on there. See that before you do that, let's try it again. You click on F of X, you click on that guy, and you want to link it to this, okay? So if you just click on the mechanism, it doesn't show that it's linked to that, but you want to link it. You put the cursor on this rule, it appears down here, and we say okay. And finally, all right. Now, let's do a simulation with laws. 10 seconds, okay? And first let's run it, and then eventually, I mean, after this thing, if it works fine, then we're going to create our sensor to make sure that these are generated for the GAs, okay? So we plot it. So this should turn counterclockwise, and this thing should move, and then it's going to sit somewhere at 8 inches. It's going to sit, and then for a while, and then the direction of the motion of the disc reverses, and this goes back to the origin. Let's see. Yeah, good. So actually, let's slow this thing down. Let me put 200 here. Slow it down, see how it goes. See, it's turning counterclockwise, block moving, and once it reaches that location, sits there for a while, and then the direction of the motion of this reverses, and this guy goes back to the origin. So good. It looks okay on the surface, so it's fine. Now let's go and create our sensor. So we want, for example, the easiest way of doing this, let's see, a reference product is that base, okay? And let's look at the block, for example. Simulation with laws, activate sensor, and notice that there's two commands here. I want these two to be yes, the length and the angle. So these are both yes. Now, move this thing out of the way, play this up. It's going to sit there for a period of several seconds, and then reverses direction for both the disk and the block. That goes back to the origin. And when you graph it, the two graphs that we had on the homework sheet should be reproduced. If not, we made a mistake in program somewhere or something else. Okay, good. Move this thing out of the way. Graphics. There. So the green one is the position of the block. Notice that first 4 seconds, the speed is 2 inches per second. Then it's going to sit there at 8 inches. And then the last second returns to the origin at 8 times the speed. or 4 times the speed, okay, which is 8 inches per second. If you look at the yellow one, it gives you the information about rotation of the disk. So 360 degrees in 4 seconds, that's what we said. That's going to be 180 per second, right? That's what it is. That's what this thing says, 180 degrees per second. And it's going to sit there at that location and return. So what you need to do, you need to give us 2 graphs, okay, both of them. Okay, so first of all, one screen capture of that, print screen. Okay, this one is right now the angle, okay, and this position, okay. So you go to Word. This is the way it's going to work on this homework and on the test final exam, okay. So paste. It shows me the scale. It shows me what is it that you're doing. This one is the angle, okay. File, save as, browse that folder, and this one is called disk position, disk angular position, disk angular position. Say okay, close that. Now select the green curve. See the scale is right here. See that? Print screen. Another Word document. Paste. See this one? The green is activated. The scale is green. File, save as, browse, desktop, homework 1, and this one is called block position, length position, block length position. Okay, and rewind, close, okay. So on the final exam, on this homework, that's what we want. We want your product. Let me see. Let's make sure we get this thing right, because I don't want any issues. I want the product, I want the 3 parts, and I want these 2 Word documents. Okay? Good luck. Before I leave, if these 2 are missing, you're going to lose half of the marks because we have no confidence that you know what you're doing. Okay? 2 Word documents along with the rest of the stuff. You don't have these. I don't care whether you put it in the same file or not. I prefer you don't, but half of the mark is gone for the homework. Okay? All right. Thank you.